All right, welcome ladies and gentlemen. My name is Brian McLogan and this is week 30 open Q&A where I am here to answer your questions and help you get started for this upcoming school year that I know, believe it or not, ladies and gentlemen, is coming right around the corner. And so it is and it can be very beneficial to start slowly getting yourself into preparation for the upcoming school year because our school got delayed a little bit, and I'm not sure how many of you also had your school delayed, or maybe you already are back in the classroom. I'm not really sure, but I do know that once things get started, I want to make sure that I have everything set and ready to go. That's why I've been working a lot throughout this summer, getting myself as prepared as I can for the classes. And obviously that's one thing that I want to, wanted to make a note on this live stream was also letting you guys know, one thing for the last couple weeks, if you've been on my channel, I have been going over some foundational skills for pre-calculus. And so we're at the end of that. I'm doing my last foundational skills tomorrow night. So if you're just joining in and you are taking pre-calculus and you're kind of interested in what foundational skills you need to know, then make sure you stay tuned to my channel for tomorrow. I'll do another live stream covering just some of the foundational problems that I know students need. And I do have a workbook that you guys can go ahead and get in PC Foundations. I believe it's also in the description of this. But then also I just want to let you guys know that I am doing something for the first time, is offering a private masterclass where I'm actually going to go through 3 keys that you need to know to crush pre-calculus. And these are keys that I actually use inside the classroom. I've been using for years and years, and I haven't put them in anything else of my instructional really material that, I kind of portray to you guys. They're not math keys or math kind of tips, but they do kind of correlate to my experience as a teacher as well as a student inside of pre-calculus. So that is something, if you're interested in, you're going to need to go ahead and register. I have the link in the description, basically brianmclogan.com/PC Masterclass. And that is something that I will be doing in the next couple weeks as I open up my course. So just another last little check. That is basically where you're going to get the details if you're interested in joining my course. I am teaching pre-calculus this year inside of the classroom, but I've also been teaching it online for my own students for the last 2 years. And I've really been working on those last 2 years, refining the course, building it up, and getting feedback from my current students. And now I feel it's a good time to share it for those of you that are looking at taking pre-calculus. So good to see J Dig. Good to see Jig, Ray, Isaac. Good to see you, Laura, Kevin W, and Aiden. Well, thank you so much, guys, for joining in. A couple of the updates that I wanted to let you guys know that if you were not in on the Instagram giveaway that I did last week, it was a really cool little experiment that I just wanted to play around with. One of the things that my live stream last week that I really wanted to do was make sure that I was still providing opportunity, because I always feel bad, when I do these live streams, is I can never help as many students as I want to. Everybody's providing questions, and I know everybody has, urgent problems that are like, I need help. And I know the frustration that so many students have when they just cannot figure out a problem. And I know I can't possibly tutor everybody or answer everybody's question. I can't even answer everybody's comments on my YouTube channel. I try my best. I really do. I spend multiple times every single day just responding to comments. So I do apologize if I never got into your comments, but keep on posting and I eventually will. But either way, one of the things I wanted to do this year was offer some tutoring sessions and just to kind of something fun, change it up a little bit on my channel. And so I'm just doing some little giveaways, some having you guys interact on my channel. And so that was something I did. We did have a winner, and we'll be getting that tutoring set up. So I will, if you're not already subscribed or following me, anything else, then just make sure you stay tuned to different contests that I'll be kind of going from there. So basically, mostly on Instagram and YouTube, I'll just kind of playing around with those two. And then Let's see. Yeah, well, I already talked about foundation skills. That is the last lesson, guys, that we have until next year, or until the masterclass. And again, if you're interested in that masterclass, the one thing I was thinking about with this is I was thinking one of my students, passed like, oh, you're making us do this math, and then you're giving us some foundational skills. It's like, I'm like, yes, I know exactly what I want my pre-calculus students to know and to understand before they step into pre-calculus. And, because once we get into pre-calculus, like other classes, things start to move fast, right? And so I have designed everything that I've created, these 4, lessons of foundational skills, plus this 3 keys to success for our crushing pre-calculus, are all created by design, because I know exactly what I want my students to be able to do and what they need to be able to crush pre-calculus this year, as well as just get the best grade that they can possibly get. The other thing, just wanted to mention for you guys that are putting in your questions, submitting to me, a couple things. First of all, for live streams, it's very difficult for me to be able to do word problems. You guys can even see my chicken scratch of writing. That's because I'm doing things very, very quickly. We're typically eating dinner and putting our girls to bed, and then I'm trying to jump in, see what questions I can answer, write them down, and put them on the live stream. So doing word problems, it's just very difficult. You can always send them over and we can kind of take a look sometimes, maybe if you have a question pertaining to the word problem. But typically, guys, I would recommend if you have word problems, put those in the Discord. They're either myself or other people that are really, really smart in that community. Have time just to kind of look over it and kind of give you some ideas of what to do. There is definitely a lot of activity going on in the Discord of basically covering all different types of math topics. And when you have questions, guys, there's a great discourse going back and forth about understanding the mathematics and solving your problems. And that goes for, statistics, physics, or just really advanced math questions. That's sometimes a lot difficult for me to be able to look at them before I'm going live and to be able to have a great answer. So, I kind of learned my mistakes early on. If you're not 100% sure of what you're doing or what you're talking about, don't take on the question, because when you go live and there's, 10, 20 people watching you think, it's like being inside of a classroom. And unfortunately, like at least in the classroom, I make mistakes and I'm like, whatever, it's like, you think about, that was a stupid mistake, and then I can correct it or tell my students. But when you're live streaming, like this stuff it's on the web, right? So, I have no problem looking like a fool or explaining to you why my thinking was wrong. But obviously I don't want to confuse people either. And so that's why I want to kind of go from there. But anyways, thank you guys for joining in at all in the second semester. Is that a problem for pre-calc? Hold on, I just saw Connor's question. So I was like, I was in Algebra 2 going in pre-calc now, and I didn't pay any attention at all in the second semester. And a lot of people lost their second semester. Is that a problem for pre-calc? It could be. Typically pre-calculus is, at least in the course that I teach pre-calculus, basically like Algebra 2 first semester, and then trigonometry and calculus topics in the second semester. So if you have a fairly decent math background and you feel kind of comfortable being able to catch up, then I would say that first kind of semester of doing a lot of Algebra 2 stuff, really heavy Algebra 2 stuff, you should be able to catch up. If you feel like you do not catch on to mathematics very easily, and it might be something that you would, struggle with, because it does go quick. I mean, I have a lot of students that they get A's in Algebra 2, and then they get into pre-calculus, and I'm like, this is the exact same stuff you learned last year, and they've already forgotten everything. They didn't really learn it. They knew what to do, but they didn't really understand. They couldn't apply it, and that's really the kind of difference with the pre-calculus, the algebra that we do in pre-calculus. It just gets a little bit more advanced. It's the same stuff. It's just a little bit more advanced from there. All right. So, and Mohammed, we got Adrian, Louisa, Jay Anderson, Amber. I'm so far away from calculus. When I get there, I'll tune in. Bye, Mr. McLogan. Your video's out for. Well, you are very welcome. And no worries. One thing I did want to mention to you guys is I put this in my email today that And again, if you guys aren't on my email list, you guys can go to my Instagram. I took over, made a little comment to you, kind of just to remind you guys, I don't really promote my email list a lot, but I do send out emails every single week to people, just kind of giving you guys updates of what's going on inside of my channel, as well as for the upcoming live stream. So you kind of have an idea of what I'm going to be talking about, as well as, just random kind of tips and tricks and videos and stuff that I am kind of doing in the web. So if that's something you're interested in, you can go over to my Instagram at Brian McLogan, and you can DM me, and we can kind of further that communication from there, and just kind of let you know, get you in on the list. I do have some other things, but I'll let you guys know about those later coming up. But what the heck was I going to be talking about? Hi, Mark M. J Dig. I was going to talk about something, but I kind of totally forgot. Oh well. Okay. Well, I'm sure I'll probably come back. Although it's not a thing. Look all right. I looked like I was a little fuzzy in my camera, but I think I was going all right. Well, anyways, I guess we'll just go ahead and get into the questions, because I don't know where it's going. So we do have some good questions that we're going to have for today. We have one problem with the logarithms. Then we have a question about double angle formulas. I looked at the student's question. I'm not really sure if I fully understood the full problem that they had, but they did have a kind of question like which one you choose, when I thought that was kind of a good question to kind of address. Then they have a double angle problem, which is a very common question. So this will be a good one to cover. We have a simplify, a square root, and then we have a limit problem. And then obviously, guys, if there are any questions after that, I will cover these math topics for you. And then we will get into any other questions maybe that you guys do have. We'll see how long I can stay on for tonight. All right, so let me go ahead and get through on there. So let's go ahead and get started. All right, so for the first question, that was submitted by Abdul. And what we need to do is they have a log 3 of x, log base 3 of x equals a, and log base square root 3 of y equals b. So find x, y squared. And this was like a multiple choice problem, and I didn't write down all the answers. Again, multiple choice, I want to just kind of show you how to approach these. And I think the best way to look at this is, well, the first thing I saw this is these are both in logarithmic form. And if I need to figure out solving for x and y, I can easily solve for x and y just by putting these into exponential form. So if I go ahead and rewrite this as exponential form, that is 3 to the a equals x. And this is going to be square root of 3 to the b equals y. Okay. Now we just kind of need to play a little bit as far as the notation here. So I have y, all right. But again, like the square root and b, like it kind of gets a little tricky. So let's kind of take a look at this. Remember that the square root of 3 can also be written as 3 to the 1/2 power, right? And then remember that the rules of exponents states that if you have a power raised to a power, then you're basically just multiply them. So this can really be written as 3 to the 1/2 times b equals y. So really, y is going to equal 3 to the b halves equals y. Okay, so now we have x, sorry, that's x and that's y. All right, so let's go and find xy. So we have x, which is, so xy, or xy squared, I'm sorry, equals 3 to the a. And then y squared is going to be 3 to the b over 2 squared. Well, again, we have an exponent, we have a power raised to another power, which is going to be multiplication. So that's basically just going to leave us with 3 to the a times 3 to the b. And remember, based on the rules of exponents, when you have exponents, when you're multiplying exponents, then you're just going to add the powers. So there you go, Abdul. Hopefully that helped you out and at least understand. I believe that was an answer choice as well for you. The next question did not come from Jason, or at least he didn't put his name, but Jason got another question, and I think they might be related. We'll go ahead and see. I'm not really too sure, but I'll give credit to Jason for posting 2 questions in there. And since they were different, I decided to cover both of them. But in reality, in this question, I didn't really fully understand what the full question they're trying to do. I think he was trying to like solve or find cosine or sine. So, but the one question that he addressed was, how do you know which identity? And I think that gets a lot of students when we get into identities, because you have options. It's not always a straightforward way. So you have to kind of think ahead and think what you're trying to obtain. In this example, we're trying to solve. And when we're trying to solve, we typically only are going to want a one trigonometric equation, right? We don't want to solve in terms of cosine and in sine. That's like solving an equation in terms of x's and y's. We want just x's or y's. It's much easier to solve for one variable. So the same thing over here. I would just choose either the second equation or the third equation. This equation is very helpful to use when you are, let's see, you could be evaluating. When we're evaluating trigonometric expressions, or when we are simplifying or verifying trigonometric identities. A lot of times I like to look at this one because that can produce the difference of two squares. But if you're doing a problem with the double angle formula and you need to solve, then I would go ahead and use this formula. So if we just go ahead and replace this to cosine squared of theta minus 1 equals 12 over 13, sorry. Okay, now it says it's in the second quadrant, or at least the angle. I believe the angle is in the second quadrant. So what's important about that is in any angle in the second quadrant, for whatever answers that you had to submit, remember cosine is going to be negative, sine would have been positive. And I think from here, you just add 1, divide by 2, and then take the square root. And remember, when you introduce the square root, you got to do the plus or minus, okay? So that is going to be the kind of, I believe, the steps that you're going to follow from there. But it doesn't matter if you choose either one of those two answers, you'll get the exact same solution. So I think this one's a little bit easier just because you add 1, divide by 2, rather than subtracting 1, dividing by -2. Doesn't really seem as much fun. All right, now let's get into the half angle problem. So in this half angle problem, you're given the trigonometric equation tangent of beta equals square root of 7 divided by 3. And the restriction on the angle beta is it has to be larger than 180 degrees, but less than 270 degrees. And then remember the double angle, or the half angle form, is for tangent of beta divided by 2 is sine of beta divided by 1 plus cosine of beta. So first thing is, let's make sense of this restriction. All right, so if we just go ahead and draw a XY axis here, coordinate grid, well, we can see that 180 degrees is going to be here, right? If here's 0. And then here would be 270 degrees. All right. So then my angle has to be inside of here. So, or my angle, like, if you go in standard form, it's going to go all the way down to there. So therefore, it has to solve in there. Now, again, if we're going to be doing our trig, we need to be creating a right triangle. And our angle then is technically not going to be our beta. It's going to be the reference angle of beta. So beta obviously is from there to there. But again, to understand the values of beta, we're going to basically use this reference angle from here to here. That's going to create a right triangle. Now, if we understand what tangent is, tangent, remember, is opposite over adjacent. So here's your angle. So we have our opposite, which would be square root of 7, and our adjacent, which is going to be 3. Now, again, remember, this is in the third quadrant. So that's actually a -3 over a negative square root of 7. You wouldn't know that by looking at the problem because it looks like it's positive, right? But negative square root of 7 divided by -3 is obviously positive. So that's why it's not written. That's why that restriction, that's why this is so important. Because if you didn't know this, you would just assume that it's in the first quadrant. But now we have this restriction. Now we just need to be able to figure out what the hypotenuse is. So we take negative square root of 7, quantity squared plus -3. Quantity squared equals c squared, right? A squared plus b squared equals c squared. So that's going to be 7 plus 9 equals c squared, and that's going to be 16 equals c squared. Cool. So therefore c equals 4. All right. So therefore c is equal to 4. It's not plus or minus because the hypotenuse is always positive. All right. So now we have all the sides of a triangle. And now we basically just need to evaluate for the tangent of beta divided by 2. So tangent of beta divided by 2. Again, we have this formula. So the sine of beta, which is going to be opposite over hypotenuse. So it's going to be negative square root of 7 divided by 4. all over 1 plus the cosine of beta, which is negative 3/4. Okay, so there's many different ways you can do this. Typically, the way that I like to look at this is get rid of the fractions. So I multiply by a 4 on the top and the bottom. So therefore, and again, as long as you're multiplying everything by 4, you're not changing the problem. So therefore, this becomes a negative square root of 7 divided by 4. And let's see, that's going to be plus a negative 3, so that's really the same thing as minus 3. And then 4 minus 3 is 1 divided by a negative 4, and therefore, sorry, that's going to be a negative 1. So negative square root of 7 divided by 1, so that's just going to be a negative square root of 7. Okay. All right, there you go, Jason. Hopefully that was helpful for you. The next question comes in from George, and George was asking how to simplify this quadratic expression. All right, so a couple different ways we want to, couple different ways we can look at this. And, you know, the main thing we need to understand, why can we simplify a radical? So to understand all of this, let me just I'm going to kind of do a foundational explanation here. Because the square root of 4 equals 2. Why does the square root of 4 equal 2? Well, because the square root of 4 can be rewritten as 2 times 2, right? That's the same number multiplied by itself. So whenever you have a pair of numbers multiplied by itself, that equals then the square root of 2 times 2, right, of that pair would be 2. And that obviously works for cube root, which would be 3 times, fourth root, so on and so forth. Well, the same thing works for variables. Like if I had the square root of x squared, that's x. Why? Well, because you can say x squared is really just x times x. So therefore, you can just say the square root of x times x is just going to be x. So one of the ways when I'm at least kind of teaching this is I tell students to look for, when you're doing the square roots, try to write this in as pairs, right? Try to write this as many pairs as possible. Any number or term or variable multiplied by itself is going to represent that pair, right? So when we're doing this, and we can do like linear factorization, we can get kind of crazy with this. I think you need to understand your factors as well as your rules of exponents, because if you understand the power rule and the product rule, that can be very, very helpful, especially when you're doing with variables. So the 5 remains on the outside. Is there 81? Can you rewrite that as a number multiplied by itself? And yes, you can. That can be 9 times 9. And thankfully, we know what 9 times 9 is, right? But we'll get to that in a second. The next one, what about q to the 5th? Well, you could rewrite that as q squared times q squared. Well, q squared times q squared is q to the 4th. So we need to multiply that by q one more time. All right. Now again, 9 is a square number, just like 4. Could you rewrite it as 3 times 3? You could, but why go through all the work? Square root of 9 is 3. Square root of 81 is going to be, that's already a pair. So I was kind of getting ahead of myself. So yes, you could break those down a little bit more, but the square root of 9 times 9, that is a pair, right? Just like 2 times 2, you can say that answers 2. So 9 times 9 is pulling out the 9, not a 3. I was confusing myself with my explanations. So here's a pair, just like we had a pair there. So that's going to be 5 times 9. Apologies. I'll do one more example to kind of explain that point. The square root of q squared, right, is just going to be q. Square root of q squared is going to be, you know what? Let me actually do this one more time, because this is actually important. Let me actually do this a different way. Because I think when I got to my confusion, this is the reason why students kind of got a little bit confused there, or I at least confused myself. If we have a pair, like the important thing about the rules of radicals is you can break them up as their products. So I can break this up as, and there's nothing wrong with actually what I did, 9 times 9 times the square root of q squared times the square root of q squared times the square root of q, which is anything left over. So again, we know that square root of 9 times 9, that is your pair, right? So that's just going to be 9. And you could break that up again if you wanted to. You could do that as square root of 9 times the square root of 9, right? But that's going to be 3 times 3, which is equal to 9 anyways. Square root of q squared is going to be q times the square root of q squared is going to be q. And then we can't do anything else with the square root of q, so we're just going to leave it outside of there. I think I'm just maybe planning for my algebra 2 return and getting some practice with that. So therefore, that's going to be a 45 q squared times the square root of q. So the point that I wanted to make is, like, what if I had like the square root of 8? Well, square root of 8 is not a perfect square, right? But you can break that in to square root of 4 times 2. And therefore, now you can rewrite that as the square root of 4 times the square root of 2, which is 2 square root of 2. So again, that is a way for you to use those rules of exponents or rules of radicals to help you break apart those radicals. So I kind of took this a little bit slower. The student just wanted the answer, but I felt like I deserved a little bit more explanation for this one for the breaking down the radicals. All right, and the last question that I have prepared here is for the limit. The student did not have actually, I don't know what the student was. I'm assuming this is what the student was asking for. But, you know, they didn't have the absolute value. So if they didn't have the absolute value, it would be the limit as x approaches 1 of x minus 1. This is how they type the problem, over x minus 1. Now, this problem is just a line. So actually, let's kind of go through what the graphs look like. To understand this problem, you need to know what this graph looks like. Y equals absolute value of x over x, okay? And that graph just looks like this. Should probably undo that. I don't want people to think it's a... Okay, and again, how do I know that graph looks like that? We'll use a table, like just use 1. 1 over 1 is going to be 1, right? What about 2? 2 over 2 is positive 1. What about negative 1? Negative 1. Negative absolute value of negative 1 is positive 1 divided by negative 1 is negative 1. And you can see this, so we have these two lines, positive 1 and negative 1, going in opposite directions. So if I was to subtract 1 from the top and from the bottom of there, all it's going to do is it's going to take that graph and shift it 1 unit to the right. So now the graph is going to look something like this. Okay? And when the graph looks something like that, all we need to now understand is, you know, the limit, for the general limit to exist, the graph needs to, or the function needs to approach our given value from the left as well as from the right. So when we look at the output value of 1, the value of this function at 1, well, from the right, you can see that it's going to positive 1. But from the left, the value function is going to negative 1. So since the value of the function is not the same from the left and from the right, when it's approaching 1, this limit does not exist. And I will just keep it for basic limits in this motion right here. In this problem, if this was actually the problem the student wanted, this would just be a line. Sorry, I know I'm kind of off the table. This would literally just be a line because this divides to 1, right? But x cannot equal 1. So therefore, since x cannot equal 1, we would just have a hole. Now in this case, you can see that the graph is approaching the same output value from the left and from the right. Now, what is that output value? Well, that's 1, right? So even though it's not defined at 1, the limit is the question of what is it approaching, not what its value is. You see how these are not approaching the same value? That's why it does not exist. Here, they're approaching the same value, and that value is 1. It just doesn't, the value just doesn't exist, but that's fine. The limit can still exist from that point on. Whew. All right, there you go. Thank you so much, everybody. I'll just kind of get into see if there's any other questions that you guys had from on there. I am live. Kyle, I'm starting pre-calculus here. Is there essentials I should know before going in? Yes, absolutely. You should definitely know about the foundational skills I've been going over for the last 4 weeks. But don't worry if you are late to it. Perfectly fine. I have there's a workbook in there that has the problems that you can just go and work through on your own. Obviously depending on when you have, classes coming up, it doesn't really, matter. But I would recommend those are the problems. There's a lot of them, and some of the problems will be pretty easy for you. Some of the problems you might have totally forgot. So I would just recommend, just kind of working through the workbook and see, what you feel comfortable with going in from there. All right, now we got some different questions. If you guys are asking a math question, I might be able to do a couple more, but please make sure you guys are just being kind of specific on that. All right. Rensley says, Mr. McGlynn, do you have any tips for AP Calculus AB? Yeah, I mean, the exact same tips I would say for pre-calculus or calculus BC is, definitely get in the algebra. When I do my foundational skills for pre-calculus, almost all of it's just algebra. Little tips like this, little things about graphing, transformations, the thing with AP Calculus, especially AP Calculus, is we do the math so quickly and there's so much kind of like repetition. So if you don't have things kind of like on the tip of your tongue, like ready to apply them, then it's going to take you much longer and that's going to get frustrating and you're not going to be able to cover as much content as you're going to need to be. And, because that's what the AP, the exams, I mean, they're making sure that you understand your stuff and that you can move through it in a timely manner. So I think the more efficient that you are able to work through the mathematics and practice a lot of those algebraic skills, you can do a lot of math in your head. And I think just the better you are going to be served for that AP curriculum, because, I think the one thing that, if anything, students struggle with in AP in my class is just the speed of the content. They can understand everything that's going on. It can make sense. It can be confusing. They can work through it, but they always feel like they just need more time. And if they had more time, they would be able to do it. And unfortunately, though, that kind of gets into a little bit of the tough thing for the pre-calc or for the AP Calc. Johnny, I'm assuming you're trying to solve x to the fourth. I don't think I like that problem, but I mean, you're just going to want to use quantity squared. I'm trying to think what you would, you can just throw that 2 in front, I'm guessing. I'm not sure, John. I'm kind of confused on that quantity squared. I'd have to go and take a look at that. But I mean, just use the product rule to get those, to simplify those down to, use the product rule to go ahead and simplify those down. But I'm not sure. I'd have to actually look at the ln of x all square rooted or raised to the second power. I'm not sure that's something. I would have to kind of work through that before I did it on here. So Zach says, I just found out that I have to take statistics, but I already took calculus with applications. Any insight you can give me in what the main difference is between the two? No, I am not sure what the difference between, calculus with applications and statistics. But I do not think that you're going to have much crossover between those two. Basically, at least on my limited knowledge of statistics for the one course that I had to take in college, and the limited statistics that I have taught in class in my classroom. But they're definitely not going to be much crossover for on there. Oh, geez. When will I be live again? So, Adrian, I will, I'll me though. All right, Johnny. Well, I'll go ahead and take a look at that. I'll look at that problem here. I just don't want to spend time thinking through everything from there, but let me just go and write down your problem. So let me just make sure, Johnny, that I have this correct. Your problem is ln of x quantity squared plus ln of x to the fourth plus ln of e to the fourth equals 0. Okay, I'll just have to go and take a look. I'll look a little bit with there just to kind of jog my memory with logarithms. It's been a while. I haven't taught logarithms in a while, and basically really only dealt with logarithms in calculus. And then obviously now getting into algebra 2, we'll get back into my logarithm method. So I'll play around with this a little bit. I'm assuming... I'll look at this and we'll just kind of see from the, I think I might have some ideas. We'll see. We'll see how that plays out. But yeah, I don't want to go through. I'm seeing some issues that I just want to look at from there. Benita says, good evening. I have a question to trace the graph 3x minus 4. Did I need to transform that to y equals? You could do that if you wanted to. obviously you can see that that kind of gets a little bit confusing, is, graphing with that fraction. There's nothing. Oh, I'm surprised. I'm sorry. I forgot. I have a different question. Student asked me to analyze this graph, so I will cover this as well. But anyway, since I did kind of take a question here, let me go over this. So yes, you can definitely go ahead and do that. I understand it's not going to be very nice. So that's going to be a negative 3/4 or a positive 3/4. Let's just make sure you have that correct. Yep. And then I can be able to do that. Yeah. So let's actually kind of look at that, because if you wanted to graph, this is not a nice problem to grade you on your accuracy, because if I said graph this, of course you could go ahead and rewrite this in slope-intercept form as y equals, 3x minus 14 over 4, right? And again, 4 goes into there, let's say 3 times and then a half, so 3.5. So it's not too bad, 3.5 from there. But if you're just graphing this, I would recommend using the intercept method. And basically the intercept method is finding the x and the y intercepts. And actually that's not going to be too much better either anyway. So yeah, I would actually just probably go from there. So let's actually do it this way, because if you do the intercept method, then that's basically saying x equals 0 and y equals 0. But when x equals 0, you get a negative 4y equals 14. That's not a nice y-intercept. And when y equals 0, you get 3x equals 14. And that's not really y-intercept. You can do it. I mean, you can go ahead and graph these. It's not crazy. So y equals what? Negative, and I think it might be easier just to write them in as decimals, like when you're trying to graph them. As far as graphing it in this form, so this is negative 14 over 4, or 4 over negative 14. And so therefore you can divide by 2, so y would equal a negative 7/2, right? Which is 3.5. If you were to graph this, again, just kind of using this way, I'm sorry, I keep on talking over myself. There you go. So y equals negative 3.5. And this would be 3 goes into there 4 times. That'd be 12 and 2, so that'd be x equals 4 and 2/3, right? 4 and 2/3, 12, 14, yeah. So 4 and then 0.666, but that's not really going to be easy. So, to go ahead and graph that, what I would recommend doing is exactly what you had. This is, rewrite that as a decimal, negative 3.5, 1, 2, 3, 4. And then you're just going to go up from there. Or right in between negative 3 and negative 4. And then you're going to go up 3 over 1. So go up 3, 1, 2, 3, and then over 1. And then you can have your graph there. So yes, that to answer the question that you thought was already right, that is exactly what you want to do. All right. Yes. Yes, 4 to ln is equal to 1. Very good. But on my question, I was just wondering if you're going to want to square roots. Yeah, you'd want to use the power rule on that. That equals 4. And then you could bring that one down in front. And I was just wondering if you want to combine those, but I'll maybe nerd out later from there. So hopefully that helps you out. ln base to the power e cancels out. Use the exponential decay applications. Yeah, those questions are easy, but I teach everything from algebra 1 through calculus, so you gotta have everything up in there. So got to make sure I cover everything, but I teach in Jacksonville, Florida, and yeah, I've taught everything from algebra 1 to pre-calculus or calculus. And just remember, everybody comes from where we've all been through the same problems, going through. So everybody's at a different stage in their journey, but I teach at Mandarin High School in Jacksonville, Florida. All right. In my country, we don't separate topics. Interesting. Okay. All right. Yeah. And I don't think there's anything wrong with that either. I think there's a lot of things that definitely need to change in the way that we teach. And I think that is becoming more and more apparent as we are kind of in this distance learning kind of situation that you can see there is probably better ways of looking at how we're educating our students. All right. So let's go ahead and, Well, Alexander, now he just caught my question because now he said he's new and he doesn't know how to submit questions. So, basically, I don't know how to submit my question. You could, but I'm new. But my question is, why is the value of sine and cosine between -1 and 1? Dang it. I love that question. All right. All right. Sine of theta, cosine of theta, -1 and 1. All right. I'm going to answer that. That's going to be my last question. I got to get to this question real quick, because this student did present it, and then I'll get done with that question, and then that should be it. I'm not going to address anymore. But anyways, Alex, to get into there, I do have a Google form in this description that you can go ahead and submit your question to there next week for me to cover on my live stream next week. Or if you need a little bit more urgent of a response, you can go into the Discord, which I have a link there as well. All right, so let's go ahead and get into fx equals 2x plus 1 times x minus 3 squared. The student was asking, analyzing the graph, like how do you know like the parts of the graph and everything like that? And I don't know what class they were taking. I'm assuming it was like a pre-calculus. So understanding the extrema is not really going to be something that I'm going to cover, but they kind of mentioned something about that. So, you know, you just want to be looking at the derivatives if you were looking for the extremas. In this case, the first thing we want to understand here is we want to identify where the x-intercepts are. And the x-intercepts are going to be when f of x is equal to 0. So again, we have 0 equals a product of two terms. That means now we can apply the 0 product property. So x minus 3 quantity squared equals 0. So in this case, you can get x equals -1/2. Here, you could square root both sides, and x would equal 3. Now, the important thing is, when we're analyzing a graph, we want to understand what is the behavior as this graph crosses at -1/2 and x equals 3. Okay, so we have x equals 3, 1, 2, 3, and x equals -1/2. So that's going to be here, right? Because the behavior is it can either cross or it's going to bounce. And what we call that behavior is called the multiplicity. So whatever the power of the factor is, of the linear factor, now these are linear factors because my x value is being raised to 1. So whatever the value of our x raised to 1, or I'm sorry, whenever our x is being raised to 1, whatever the power of that factor is going to tell us that behavior. And if that power is even, that means the graph is going to bounce, or it's going to behave like a quadratic or a quartic. And if that power is odd, like 1, then it's going to behave like a line or a quartic or a quinctic. It's going to cross at the x axis. So in this case, we have a multiplicity of 1 at -1/2. That means it's going to cross. So it's going to cross like that. Now this one, it has a multiplicity of 2. That means it's going to bounce. It's going to behave like a parabola. But do we know, does it bounce up or does it bounce down? We don't have enough information for that. So the last thing we want to do is look at our end behavior. And to look at our end behavior, we need to think about the leading coefficient of this polynomial, because this is in a factored form. Well, if we were to expand this polynomial, basically take x minus 3 squared, expand that out, then we get x squared, right? So we'd get something that would be, 2x plus 1. And let's not do the math. It'd just be x squared something, right? It's not going to be x to the 10th. It's just going to be x squared. And if we were to multiply this, then we'd have 2x squared something. But nobody wants to do the math. We'll just leave it like that because we don't need to know the math. We just need to know the leading coefficient to find the end behavior. And the leading coefficient of this end behavior, that's a cube, by the way. 2x times x squared, right, is 2x cubed. When we have when we have a positive coefficient and a odd degree, then we know the graph is going to fall to the left and rise to the right. So this graph is going to look something like this. No, I forgot. So it's going to look something like this, and then it's going to bounce and go like there. Okay, so the student was talking about like how to find also like this extreme, because it is increasing and then it's going to be changed into decreasing. You want to use some calculus to go ahead and identify. These are what we call our extremas from there. But hopefully you can see that the graph is increasing, goes down to decreasing, it's increasing. You can see how the x-intercepts play a part. You can also see how the multiplicity plays a part. And the only other thing that would be useful, or a lot of times that we find useful, is the y-intercept. And the y-intercept, again, remember, is when x is equal to 0. So if you just plug 0 in for there, so you have f of x, that equals, let's see, that'd be 1 times 9. So that would be 1 times 9 is 9. So, right? 0, -3, -3 squared is 9. Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. Perfect. All right. Last question I just want to cover real quick is the sine of theta, cosine theta. Why is it between -1 and 1? I think this is a great question. And it's a question that the reason why I think it's such a great question is because it's a question that I had and that I never understood until I became a teacher. So I went through all of high school, all of college, got my degree, like did crazy advanced math, problems and stuff like that, but it's not like something I was constantly always thinking about. But, I remember one time when I was teaching, it dawned on me, I'm like, oh, that makes all the sense now. Like now I understand that. And throughout like my whole education career up to the point of becoming a teacher, it just never dawned on me. I just never knew it. I never had to know it. But then it was like one of those of like, oh, now things kind of make sense. So let's just kind of look at this real quick. It's definitely something that I am pretty passionate about, that maybe might even be a video idea later on. Okay. So if we have a triangle, and let's call our theta here. Okay. So here's our theta. That's going to be our adjacent. This is our opposite side, and this is our hypotenuse side. Okay. Now, if we're trying to find the sine of theta is the opposite over the hypotenuse. That's what most students remember from trigonometry if they did it in geometry class or wherever else. They remember that opposite over hypotenuse, but it doesn't really make any sense to them. Like, what is opposite over hypotenuse? If you think of this as a ratio, the sine of theta is a comparison of how big is the opposite side to the hypotenuse. Now, the one thing we remember about a right triangle is the hypotenuse is always the largest side, right? So the opposite side can never be larger than the hypotenuse. Most students remember that. But also, the opposite can never be the same measurement as the hypotenuse. Because if they were the same measurement, right, you wouldn't have a triangle. The hypotenuse has to be the largest side. They cannot be the same length. So what that means is that is going to be a 1 over 1. That is not going to produce, now it's going to get into there. So if you had 1 over 1, obviously you can still have the sine of theta is equal to 1, but that's not going to produce a triangle. And that's why we use the unit circle, because you can have sine of theta is equal to 1, right? But it's not going to produce a triangle. It's going to produce this 90-degree angle. And that's why we use the unit circle to deal with like the 90 degrees. So that's why 1 is included, but it can't be anything larger than 1, right? In terms of the triangle, it can't even equal 1. That's why we have to think of this in terms of the unit circle. And the same thing goes for like -1. Well, actually, it doesn't really matter to go on the same for. If -1 would just be the same thing. It's just the negative ratio, negative angles, same thing. But the other thing I wanted to mention, which I'm not sure if you mentioned, was the, well, I guess, yeah, in terms, same thing would be 0 too, right? So the sine of opposite or hypotenuse, the opposite side also can't be 0, at least in terms of a triangle, right? Because if the opposite side was 0, you wouldn't have a triangle that would exist. And again, that's why we look at the unit circle to represent that, oh, actually we can still understand our trigonometric functions by the unit circle, but not so much looking at drawing a physical triangle. But that's why those ratios exist, because again, remember, sine, cosine, tangent, cosecant, secant, cotangent, they're all comparisons. All you're doing is comparing one side of a triangle compared to another side of a triangle based on your angle, whatever your angle is, theta, alpha, x. And just remember, for the hypotenuse is always the largest. So if you have opposite over hypotenuse, it's never going to be larger than 1, right? Or it's never going to be smaller than -1, because the ratio, the hypotenuse is always going to be larger, right? So you're always going to have a smaller number in the numerator compared to the hypotenuse. And that's always going to produce you a decimal between -1 and 1. So there you go, ladies and gentlemen. That is it for this open Q&A. Again, just a reminder, if you joined a little bit late and you are taking pre-calculus and you have maybe joined me for my foundational skills, our training videos, I am doing my last live stream to prepare you for pre-calculus this year. That is going on tomorrow night at 9 p.m. And then after that, I will also introduce my masterclass that I am covering for those of you that are taking pre-calculus to, in addition to all the math you need to know, but what are the other keys that you need to know to crush pre-calculus this year? And these are some tips that, definitely I work with my students throughout the whole year. And obviously I am opening up my pre-calculus course on August the 3rd. So these are going to be some of those tips that I want to introduce to you guys in preparation if you would, kind of learn a little bit more about the pre-calculus course and see if that is something right for you. But either way, it is a lot of good training to go through, but it is a private live stream, is that masterclass. So therefore you need to go ahead and register. I do have a link, BrianMcLogan/PC Masterclass. If you're interested on that, if you just want to catch up on the math for pre-calculus, then go to PC Foundations or BrianMcLogan.com/PC Foundations. Again, that link is also in the description from there. Otherwise, guys, if you have questions for next week, make sure you guys go ahead and submit them in the Google form. Or if you need something a little bit more urgent, then go ahead and utilize the Discord. And there's a lot of people that are helping each other out, and also, help some other people out too is there as well. Because one of the, things that you can definitely jumpstart your learning and understanding mathematics is being a part of the dialogue of helping other people understand the math that they're doing. And I think the coolest thing about the Discord that I actually like the most is the variety of types of problems that you have. Like people are like, oh, I'm taking pre-calculus, but all these different types of pre-calculus problems or calculus problems that people are getting from their different courses and everything. It's really cool. And, especially something that if you're in a certain class or, school or district, like everybody has the same textbook, everybody has the same, worksheets and everything like that. And that's fine. That's cool. But it doesn't really get you to expand or get used to other different ways of asking questions or similar problems. But one thing that I've really noticed is the variety in the content is really, really been cool to look at, and also has opened up a lot of my eyes in terms of mathematics as far as teaching and everything like that. So anyways, I hope you guys have a great evening, and hopefully for those of you that are interested in pre-calculus, I will see you tomorrow for another live stream training. Otherwise, guys, have a great week. We only have a couple more weeks left of the summer, so please go ahead and enjoy them. But I look forward to helping you out through the school year and seeing you guys next week for another live Q&A.